Hi, welcome to Team 14's Band in a Box final demonstration and presentation. My name is Shawn Theetge and my teammates are Herminio Ortiz, Alexander Milbert, and William Lewis. On slide 2, you will see the instruments that our team has created. On slide 3, you can see that we chose the ASU alma mater and which instruments are responsible for which parts of that song. On slide 4 are our selling points. We have a very unique design set, but we also use tried and true designs to reproduce certain tones and frequencies. And of course, all instruments can easily fit into a stackable and portable 2 cubic foot stage box. Slide 5 are our team's goals. Our goals were to gain an understanding of the engineering process, which I believe we did very well this entire course, and to create a band in a box instrument set using the criteria set forth from previous assignments. Slide 6, we're moving on to my musical instrument, which is the pan flute, and you can see it starts from a very rough sketch design and slowly morphs into what you see here today. Now I'm going to provide sample tones for you. On slide 7 are my important unique design features for the pan flute. It is a very compact design. It can be made out of any tube material. The underlying physics of this design is that because it is a closed-ended instrument, wind instrument, the antinode of the wavelength is at the open end and the node of the wavelength is at the closed end. The final cost of this design is $4.34. On slide 8 are the challenges that I faced, and one of them was getting the lengths of the tubes just right to get the frequencies that are required to play the song. One of the lessons that I learned was I should have used the equations and formulas first to design my pan flute rather than creating an arbitrary design and then using the equations after the fact, which would have saved time on the design process. And finally, some design improvements would be to use metal tubes and brackets to hold the tubes in place rather than tape and PVC piping. That concludes my portion. Moving on is Herminio Ortiz with his percussion instrument.
Thank you, Shawn. Hi, I'm Herminio Ortiz from Team 14, and this is my percussion instrument to play the mid-high voice in ASU's alma mater song. Quick little demonstration. Here in slide 9, I have the initial sketch followed by the review sketch to create my final product. Here in slide 10, some of the important and unique details about this instrument is how clear and unique the sound created by combining the steel bars and the wooden box for amplification came out. It came out really nice. Another unique characteristic is how it resembles a drum and a xylophone, but has a complete different look and sound. Here's a percussion formula I use to distinguish the different frequency waves from using steel bars from 2 to 10 inches lengths. Total cost of the design is $14.21, all purchased from Home Depot. Here in slide 11, some of the challenges was to keep the cost down. Another challenge was creating the right amplification of sound with different wood materials. Some of the improvements that I would seek was to use a different, thinner metal bar while keeping the quality of the sound and adding more metal bars to add additional sounds. Another improvement is to do more research on the material to have more room in the budget for adding more detail and decoration. Here next we have William demonstrating his instrument. Thank you.
Hello everyone, this is William Lewis with Team 14. I'm going to be discussing slides 12 through 14. On slide 12, you'll notice I originally started with a PVC stringed instrument and eventually tailored it to a more traditional guitar type instrument. On slide 13, this design is unique in that it is fretless and made completely out of wood, a Rubbermaid bowl, 8 screws, and nylon cord. The overall length of this design was maintained from the previous design to incorporate the appropriate amount of string needed to create the tones for E1, A1, D2, and G2 on a bass instrument. I utilized calculations to determine the overall string diameter for each one of those notes, as well as compared nylon and wire to determine which type of string or wire would be more beneficial for this type of instrument. The overall final cost for this design was $6.88. On slide 14, the first challenge I faced was creating a completely new design as we went over the maximum amount of PVC used, and also tuning the chords to play the appropriate notes. Some possible design improvements are finding an alternative for string or wire, and also using something more durable than a Rubbermaid bowl for resonance, such as cardboard or wood. I'm going to pass you off to Alexander now to finish out our course. Thanks.
Thanks, William. I was in charge of the low voice instrument. What I really liked about this, some unique design features, was the handcrafted wooden mouthpiece that I made in order to help generate the desired frequencies from the PVC piping tuba-like instrument that I created. This PVC material was very easy to assemble and take apart so that it could fit into something like a 2x2x2 box. And the underlying physics of this design were basically I measured out the lengths of the holes, and that helped determine the notes to play in order to generate the desired frequencies. The total cost of this was $12.91 for the paint, the PVC, and also for the wood. Now, some challenges was, of course, creating a mouthpiece. I couldn't just use the piping, and I couldn't use anything made out of metal because that also wasn't working. So creating essentially a wooden mouthpiece took a very, very long amount of time. I also had to make sure that the hole openings provided correct frequencies, and this took measuring through Audacity. Some possible design improvements would be creating a smaller compact design or restructuring the cone amplification device. Now in total, Team 14 had a total cost for $38.34. We realized, that every project takes multiple designs. There's some unexpected obstacles that always arise, but team communication is the key to success. And these designs are always going to evolve, but that's how we succeed. I'm Alex Milbert, Team 14. Thank you so much.